have Agnès Boudot from Atos with us today. Agnès is the Senior Vice President for HPC, AI and Quantum, and she is also the CTO for the public sector and defense industry. She will take you through how computing power is the key to tackle tomorrow innovation challenges, and she will highlight very concrete examples in this session. So please use your Q&A function to post any question you have for us. We will take time to answer this at the end of the session. And Agnès, the floor is yours.
Hello, everyone, and I'm very pleased to have you for this session. Let's start with this presentation. And so HPC, high performance computing, and for the 21st century. How do you see this for the future, and how do we plan to go in the next years with really innovation and interesting technology? So we've seen from all these last years and decades that any times there were some crisis times, it was the time also for leaders to emerge through innovation. And this is exactly what could happen, and especially with HPC, with HPC, where we do have a very interesting evolution, innovation story around this subject. I mean, we are definitely, and in many areas, having this exactly time for moving forward to increase our way to bring innovation into real challenges, and this is across the industry. HPC is really the engine at the heart of digital economy, and connecting big data, AI, and cloud computing. Sorry. You all know probably that the HPC world is seen and dominated as for now for some decades by several countries. If we are looking at the systems on the top 500 ranking, we see a very big presence of different countries. China is leading in some areas. US behind if we look at system shares, and we do have Europe and Japan as well. But if we look at power computing, we do see a lot of American companies still there. What is interesting is that even if Europe today is behind the big race and behind in terms of very large system, we are catching up, and especially Atos being the single HPC supercomputer company, we are doing more and more today to be present. We are first in Europe, we are first in South America, we are first in India to bring really these HPC supercomputers to the countries and to really help in developing. What is important is two aspects. I mean, the economical aspect is definitely important, where HPC creates an average return on every dollar invested, $500 in GDP in the different economy and industry, and also for sovereignty reasons. The thought of HPC has been for many years around military research and to provide tools for this specific area for the countries, but it has, of course, evolved a lot in these last 50 years, and we do see HPC basically everywhere in the economies. And we, of course, what is very important, it has been always the sense of HPC. Of course, it's to have heavy compute power, but it's to manage the data. It's to manage the flow of information. And we are entering a new trend combining HPC, traditional simulation, compute simulation, and AI for the future. So getting all the best from the data. And this is exactly what is happening today. And Europe, Atos, is more and more present and giving these features, these elements to all the scientists and research community that needs this. Let me just switch to the next slide. So how do we work around all these? As I said, there's an amount of data that has been increasing for years, and it's just the beginning, I would say. I mean, with all the IoTs, with all the capture of information that is coming from everywhere, with all these social media information, with all the IDs information from people, with all the consuming elements. I mean, all this data, all the manufacturing industry, all the capture, all the information that is around each element of industry. When we talk for weather forecast, when we talk manufacturing, when we talk any kind of business, the interest is, of course, to compute based on data that are inputs to a computing simulation, and then, of course, to get to some results, to get to some analysis, to get to some additional post-treatments. So this is definitely the trend, and it's more and more present for us today. So we are really with HPC, with computation, with quantum computing even, we will discuss that a little bit later. We are absolutely pushing all these elements. And of course, we need to ingest this information through the supercomputers. But I mean, this is also part of the full story of what we can do and how we bring all the elements to the compute power of a supercomputer. If I look at what we have at Atos in our portfolio, we have a lot of different, let's say, bricks to bring tools to the users, and this is exactly what we are trying to achieve with our portfolio line. I mean, we do have, of course, very large supercomputers. We've been developing this for 15 years at Boudot previously, and then now Atos is continuing that extraordinary story for Europe. We do have Boudot Sequana S systems in the middle, and it's in-memory apps, data lake type of applications that you can use, or, I mean, really intense memory, big scratching of research. We do have additional servers as well, up to the edge servers, and of course, what is very important to us, behind the design of the server, we are integrating some technology partners for the compute engines, but our trend for the future is, of course, to work on European technology. And as part of that story, the EPI initiative with the emerging in the future of a European processor is key to us, and this is the trend where we want to go. Atos supercomputers are a long story already. We have been the first in last supercomputing event last November to announce our large Boudot Sequana XH2000. That's our really high-range supercomputer type. We are able to integrate the most recent and latest and highest performance technology. And we broke several world records with AMD EPIC second generation processor at this time. Since then, all the announcement that we had made in the last month, we have installed a lot of supercomputers based on that technology, including also the HDR InfiniBand technology, that is the high performance networking that is the most performant available at this time on the market. So we are really always ahead of what is available around technologies. When we think about how to get the best of a supercomputer, and when we think about how to compute fast, how to really be able to have all these elements around HPC and all of compute power servers, and how to really feed the compute engine, we do develop several software elements, what we call software stack for HPC, and we are combining HPC and AI elements and software suite to be able to really have this convergence of usage, which is developing more and more, especially with the technology of accelerated technology with GPU, for instance. and we are pushing the limit, and we are again ahead of a lot of other players, bringing together all these elements within a single supercomputer. I'd like to also spend a few minutes giving a view of what we do when we talk about AI augmented solutions. It means that we are embedding in our solution also AI technology. And I will just take the one example out of that slide, the connective data center. What we do basically is we are able, through a software layer, that are software elements that we bring on top of the supercomputer or on top of a big data center that works as well for any kind of, let's say, compute element or server in the data center. We are putting AI in terms of having predictive maintenance and predicting production workloads optimization. So we are bringing a software stack, software elements that help getting the best of the production environment. And this is absolutely key. This is not restrictive to that product. This is a full initiative that we are pursuing to really bring AI every direction in our solution, on top of the, of course, application developed by the customers, by our customers that are based on AI technology. Now, in the second phase of this talk, I would like to give you a few examples of where we are today in terms of application and industry. I'll take 4 examples: healthcare, meteo or weather forecast and climate, manufacturing, and lastly, I'll talk about smart city initiatives. Just to start with healthcare, it is absolutely key today, as you all know. And this is just an example with one of our customers, University of Oxford, for which we are, with which we are working for many years already on AI and developing deep learning type of applications. The idea behind that is to use HPC, traditional simulation, and AI, and the idea is to develop drugs and vaccines, for instance, to help on some, research related to cancer, cardiovascular type of research, and a lot of work in healthcare related to how we can improve research, how can we shrink time in between discovery of a problem and solutions, how we can speed up the vaccines way of findings, and all these subjects are absolutely key. So it is an example with University of Oxford, but this has been for, let's say, the last 3-4 months, a big push from all of the customers. Most of them have opened their supercomputers for COVID-19 research, and it's true in any country because, again, this type of solutions, supercomputers, are really key for sustainability of the country and the states. So this is absolutely key to bring these tools, for sure to the industries, but also, of course, for the research community and so on. So that was the first example. Supercomputers are key today in all the research worldwide and in every country. And for us, it has been true in India, it has been true in Brazil, it has been true in Finland, it has been true in Czech Republic, of course, in France, in Germany, in the UK, and so on. Next example is related to weather forecast. I would like just to take an example with the work we've been doing for now since 2013 with Météo France. We've been awarded in 2013 for a 5-year contract. We've been awarded again in 19 for the renewal of this weather forecast supercomputers elements. What is important is really to understand from the HPC environment why we are using HPC and for what. Basically, there are many types of research that can be done and to predict and to help on the weather and climate forecast. It is a very sensitive topic, as you know, with the climate change. I would say that HPC has never been more present with weather climate change than before, and it's still increasing. And what we see for customers, basically, they try each time between each renewal and typically 5 years contract, they would try to multiply by 5. It's a quite common number that we have seen for the last decade, by 5 the compute power they were using. And the idea behind that is to be more predictive, to predict in a shorter time, but also to be more accurate and to have a more precision in the way they are producing results. It's a very, let's say, simplified view, but it's very true. And we are present in different countries now, and we have several customers that have renewed with us with such research. It's not only bringing supercomputer, but it's also bringing production tools. I mean, really supercomputer for production, not only for passing records and on real applications. You might know that 30% of the impact of the climate change will touch 30% of the industry GDP in all directions. So it is an absolute key element for having HPC that is providing appropriate tool for each state and country. Another example would be in the manufacturing. Let's say that these supercomputing elements have always been in that area, in that industry for many years. And instead of taking from the beginning 60 months, let's say, to develop a car, the HPC technology have helped improving the design and the development of this. A very recent area that is mixing HPC and AI is autonomous driving, and it's all the learning, it's all the elements that is helping in bringing additional feature, of course. And we are combining traditional simulations for, let's say, a CFD type of application, but also on this machine learning type of things. There's a lot in inference training. You need to manage a lot of data, and you need to push this story and the capability of the HPC system to a much larger spectrum that it used to be. Last example would be smart city, and the smart city is very interesting because inside our evolution of HPC, it has never been, by the way, only a central big machine. It has always been a machine that is dealing also through workflows with pre-processing, post-processing, and so on. And what is interesting in smart cities, let's say that you put cameras in a city, and then you need to have edge servers, you need to have AI at the edge level, you need to have communication through to data flow, to have the data moving through speed and secured network. This is very important. Cybersecurity is, of course, present. And through this, you ingest and you feed your supercomputer. You need, of course, data lake. You need a lot of information. You need the data sciences to help you. And it has all to do with managing the full workflow. And this is typically the kind of project that we do at Atos, manage end to end. So I would not finish before I talk about expertise, scientific knowledge in all these areas that I've touched. I mean, this is key to know that within Atos, what we do is on top of building the solutions, we are also bringing to the users a very wide range and support and services team, of course, to deploy this kind of infrastructure, but more about also working and helping our customers in finding the right application workflow to help optimizing, to think about how to manage the data, and so on. So we are bringing all these kind of elements. Last but not least, a very let's say, interesting, futurist, but not only future, present always, as for a few years now. For 3 years, when we launched in 17 the Atos Tech Days with the quantum learning machine, we have decided as Atos to put us on that business of quantum. Quantum is the future, but it's also something that needs to be worked out by the companies now. And with the quantum learning machine, we do provide simulation tools, and we help developing algorithm for the future. What we see, and for sure, we will be. We are convinced that we're going to see this technology as well in the future in the supercomputers element. That would be probably some part of the supercomputers, specific island, let's say, with quantum technology to address specific type of algorithm that can only be seen and used in that area. I will just go very quickly on that one. Besides the QLM, the quantum learning machine simulator that we bring to our customers, and before we give in few years an accelerator that we are working on to put into supercomputers, we have developed some tools and software tools where it goes MyQLM. It is a very powerful tool to help develop, support, and also bring and share information through the usage, the community of quantum developers. So to finish with this, it was very quick. I wanted just to highlight again the presence of Atos, the future of us in terms of increasing our presence. We are on a growth in that area. We are absolutely committed to bring this new technology and the best of breed technology to our customers. We are inserting in our, let's say, supercomputers, the latest and advanced elements, the one developed by us, the one that we are integrated from the community of technology partners. But what is very key is that we want to be present and to bring what is needed for the state sovereignty and what is needed for all the human beings and the society to be at the right level with their industry, with their economy, and with their sustainability of these activities. So that's it for today. I will turn it back to Jean-Christophe.
Many thanks, Agnès, and thanks for these very, very interesting insights. We've received some very interesting questions here, and we will take the time now to answer this. First question, so far, what is the place of life science among HPC domain applications? Do you think, Agnès, that the use of HPC on COVID-19 research works could increase its use in healthcare and life science domain? And let's first answer this first question, and we'll go back to other questions after. Agnès, the floor is yours.
Yeah, so life science is definitely a very present field in the HPC for years. I mean, it represents a lot of researchers, especially in academic centers. We do have an enormous community of people working in that area, and definitely there's a lot of work around COVID-19 research. But I mean, not only, of course, this has been an increasing level of demands across, worldwide community in life science for that. All the centers and all of our customers in that area, I'm thinking about GENSI in France, Jülich in Germany, the CDAC in India, LNCC in Brazil. All of these customers that are hosting these large entities for their scientific community have opened special, let's say, programs to give access to the research for this COVID-19. And definitely we do see that at Atos, and it has been a fully common way for all the, let's say, research centers. I think it's the same, of course, in other countries where you do have also other suppliers. I mean, definitely life science is heavily present in terms of ranking, in terms of usage and split in the usage of supercomputer. I would say that it's probably 15 to 20% of the usage, traditional usage, and increasing this last month, certainly.
Many thanks, Agnès. I think we have the time for last question. Just a question on quantum. When do you think that quantum accelerators may be available in HPC? And if it's what is probably the case in a few years ahead, why is it important to begin to prepare right now for enterprise in all sectors? Many thanks, Agnès. The floor is yours.
It's hard to say, but I mean, we have announced last year, I believe, that we're going to be ready by 2023 to have a quantum accelerator at Atos in our supercomputer. So we are working this path and we are on track for that. It means that we are not at Atos working on a full quantum supercomputer, but we are working on quantum accelerations, meaning having some specific device that we will integrate in our supercomputer and that will be able to accelerate really some specific applications. What we know for the quantum business today, and I think it will evolve because we've seen that with other technology in the past when, let's say, if I make a comparison, when we had the GPU type of acceleration in HPC, it has started slow and now it's going and it's increasing a lot. But I mean, yeah, we are on that path and we are targeting to have this in 23.
The end of this session. Many thanks for your great insights. And thanks to all of you for being at this live session about HPC. The recording will, of course, remain online for all of you on the Tech Days slide. And once again, many thanks and happy to see you in further sessions. Have a good day.